this point, now I think it pairs very, very well because we have the speaker, Mr. Tsegis, Christos Tsegis, which exactly is going to speak us, I think, for the charges. Yes, Mr. Tsegis, I can see you. One moment. I think you have a presentation also.
Thank you very much for the invitation, Mr. Lupagidis, and for the great initiative. Before starting with the presentation, I would like to introduce briefly myself. My name is Christos Tsegis. I'm an electrical and computer engineer and have been working for the last 2 years in the sector of e-mobility. So it's really glad being here with you actually and sharing also my points and my vision actually on the e-mobility sector. And my presentation is mostly focused on the European incentives and also on the charging infrastructure. So I think you can see my screen.
Yes, we can.
So the main part, actually, the first part is regarding the European incentives, the public incentives on the charging infrastructure, and then a transition towards the CO2 emission mitigation, infrastructure regulations that have been applied across European member states, and the transition towards the recovery and resilience facility in Greece and how we can deploy efficiently the charging infrastructure. As we have seen in the last years, a lot of European member states have posed a lot of incentives in terms of purchasing battery cars and also plug-in hybrid cars. On the left side, you can see which are the incentives in some European member states, and also this coupled with the ban of IC cars in some towns and some countries across Europe. We can see a tremendous increase on the electric cars in the last few years. Moreover, in Germany, that I'm currently based, we have also since November 2020 a lot of incentives, not only in the public, for the public initiatives, but also for the private initiatives for purchasing a charger. And more precisely, this is 900 euros per charging port. If we compare this actually with some other European countries, this is quite a high level, and therefore in the last months, the increase of the charging infrastructure in Germany has been increased exponentially. On this slide, actually, I would like to stress out the recovery and resilience plans, which is scheduled for 2021 to 2027. And this contains some flagship areas. More precisely, it's about increasing the green energy, increasing also the digitalization and scaling up the e-mobility infrastructure across European member states. Greece is also participating in this facility, and all member states are going to submit their proposals by the end of this month. As we can see here, there is a mix of pure electric cars and plug-in hybrid. And with a light blue line, we can see the absolute numbers in each of these member states. As we can see, Germany dominates across the whole European countries. And in fact, in 2020 has achieved approximately 400,000 stations, 400,000 electric cars. So the plan actually in Europe has been amended, and in fact by 2030 it's called the Fit for 55, which targets actually to 55% mitigation of the CO2 emissions. This coupled actually with sources that we can have actually from the European Automobile Manufacturer Association, we can see that between 2021 and 2030, we have set a very, very high target on mitigations that will reach 50%. In other words, this is translated actually to a very, very high number of charging points across European countries, and more precisely, the mixture of private and public places is going to reach approximately 60 million in order to achieve this high number of CO2 mitigations. At this point, I would like to have also a transition to the e-mobility in Greece and also the recovery and resilience plan in Greece. The allocation sources for time being are going to be set to 29 billion euros by the end of 2027. But before actually having this transition plan, we have for sure to enhance a green transition in the country, to have a digital infrastructure, and of course to make a core value in the society, not only in the university or at work, but also in the school of the people, to understand which are the values of sustainability and also of e-mobility. So if we see actually the allocation of these sources here, this can be efficiently implemented by having a private investment and also an institutional transformation that can force us towards sustainable e-mobility infrastructure across the country. As my current position is mostly on the sales engineering of charging infrastructure, I would like actually to stress out which are the main features of charging infrastructure, which is a core technology in order to facilitate and to accommodate the EV cars in the whole country. So, as we saw actually from previous presentations, the charging infrastructure in Greece is pretty much at a low level for time being, and for this actually the incentives that are going to be implemented are going to increase the number of chargers. But what exactly is the charging infrastructure? Here we have two types of charging infrastructure that follow the international norms 61851. These are the standards, the IC standards. And we have the AC charging station, which is actually from 3.7 up to 43 kilowatt. Mainly we can see a range of 3.7 to 22 kilowatt because this is the need of most of the electric vehicles. And juxtaposed to AC charging stations, DC chargers are a bit more sophisticated as they supply a direct current to the battery of the electric vehicle. And therefore, this is the so-called fast charger. For the AC charging, we need actually the onboard charger, so the conversion of the power is happening actually within the car. These are actually two photos of two projects that I was currently working on. On the left side, you can see how AC chargers look like. And on the DC side, it's actually an installation of DC chargers. As I mentioned, DC chargers could range up to 350 kilowatts. This is the current actually common power in the market, and basically it's either composed of a power unit that incorporates the converter of the unit, the transformer as well, and the user unit that is the interface to the car, or it comes actually as a compact solution, like one unit, that includes the cables and all the electronic boards. This slide, actually, I would like to analyze a bit further because this is the roadmap. It's quite technical, but this is something that we can also bridge between Germany and Greece. As in Germany, we have run a lot of projects and we are still implementing new standards. And we have various use cases that are actually working effectively. And this is actually, in terms of business, a very good cooperation with the technology and companies that are in Germany. So the first point, as you can see, is the ISO standards. This is new standards in e-mobility. ISO 15118. These are the standards that define security transfer of data between the charger and the car. OCPP 2.0.1 is the new protocol of Open Charge Alliance. In fact, if a station actually is monitored and transfers data, this is the communication protocol. This is the Open Charge Point protocol that the station communicates to a backend system. Currently, we are deploying the new standards, that is the 2.0.1, and this is coupled with a lot of features of the ISO standard. This is mainly going to be deployed within a lot of charging manufacturers by the end of this year. The other point is the more chargers we have, the more we have to seek on having the stability of the grid. And a main role play on this, the energy management systems. So a proper integration via specific communication protocols to energy management systems will give us a cutting edge in the market by achieving a proper allocation among all the charging points. Another major topic that a lot of companies actually are in the integration and implementation phase is the vehicle to grid. As we can see, a lot of manufacturers have recently announced the support of vehicle to grid, which is actually vice versa of the charging process, is the feed-in from the battery to the grid. And at some point, this is mandatory in order to achieve the grid security. Another point that is very, very crucial in Greece, as we all know, Greece has an abundant amount of renewable mix that comes primarily from solar energy and wind energy across the whole country, and especially we have a lot of microgrids on some islands. This combined actually to charging infrastructure, supplying in fact the charging infrastructure, could, of course, end up to a very, very good business scenario and a lot of solutions in Greece if we combine, for example, with solar or wind energy. The last point is that, of course, is a critical point to deploy in Greece is to find the mobility service providers. Mobility service providers actually communicate with charge point operators. And let's say, in other words, they just have an application. It's very, very easy for the end users to find where charging stations, either AC or DC, are available on public charging, and therefore charge their car according to the network that works on a country level or on a European level. So this is basically my presentation for this. Of course, I'm at your disposal for any further questions. Thank you very much for having me here.